Before we actually connect our API to Postgres, we'll want to create a database and tables with the proper schema for storing users. One approach that makes this process more reproducible is just to write a SQL schema script that handles creating tables for us. Database migration scripts are another excellent approach, but for a small-scale application like ours, they won't be necessary. We're also going to need to create a SQL script to handle the database, well, at least handle creating the database, and then to run our schema SQL script. So go ahead and create a wedding registration schema SQL file and a wedding registration.sql file. So we will touch wedding-registration-schema.sql file and a wedding-registration.sql file. So two SQL scripts here that should be in the root of our project. Good, everything's there, looks right. Fantastic. Then you're going to add the following to the wedding registration schema SQL. Sorry, that one's tough to say. We'll come in here and we're just going to write a tiny little bit of SQL that's going to create a table for us. So the syntax for creating a table with SQL is to say create table, and then we're going to create a users table, and then we're going to define the schema for that table. So the schema is we're going to have an ID field that is going to be serial primary. It is the primary key. And serial just means it's an auto-incrementing integer. We'll have a password field. Let's move that over a little bit. And the password field is going to be text, and we do not want it to be null. And an email field, which will also be text, that is not null. And we want to make sure that these are unique. And we also want to check, let's put a check constraint on it, that, and we'll use the position function, that the @ symbol is in the email, and that position is greater than 1. We'll also have RSVP status, and that will be Boolean, that it should not be null. And we will have num guests, which will be an integer that is not null. We'll also want to timestamp these, so we'll say created at, and that will be a timestamp that is not null, and it'll be defaulting to now, which is a Postgres function we saw earlier, which just gives you the exact timestamp for this moment. Bear in mind that we're only including the minimum fields required by our client, because they just asked us to allow people to register, get the status of their RSVP, are they coming, are they not coming, how many guests do they plan on bringing, etc. And we're only storing this in a users table, though probably if we wanted to get serious about this, they'd probably have their own dedicated table with other user info like first name, last name, and in fact, it's likely that our client might eventually ask us to store the names of each attendee's guest as well. But let's relegate all of that to the V2 version of this application. Again, we have this nice check constraint here that you may not have seen before, but all it does is ensure that the @ symbol appears in the email and is not the first character. To give you an idea of like what exactly that's doing, if you go into pSQL, again, which is the Postgres interactive terminal, you can actually select this. You can say select, you can run SQL right in pSQL. You can say select position, and we'll say is the @ symbol in, and let's just make a fake email here, user@email.io. And let's see what that query tells us. So the position is 5, which is indicating that the @ symbol is at 1, 2, 3, 4, 5 in this string. And so you can see that all this check constraint is doing is it's ensuring that the @ symbol is not the first character in the string and it does exist. Because if we were to do that exact query and we were to take out that @ symbol, for instance, we would see the position is 0. Cool. So nothing too crazy there, just some generic SQL. And if you haven't seen this before, just know that, again, a nice Postgres refresher might be useful. And it might also be useful to go to the Postgres documentation, because the documentation is pretty fantastic. It is particularly thorough, so it can be overwhelming at times, but it is a good thing to at least skim over and check out if you have the time. Cool. So let's go ahead and modify our wedding registration.sql script. We'll at least save this so that it will create the table, the users table we need by running this script and doing some other database management stuff as well. So head into here and let's write a little bit of SQL here too. We will echo delete and recreate wedding registration DB question mark. And then that's basically just going to print it to the terminal whenever the script gets run. And then we will prompt the user, and we will say hit return for yes or control C to cancel. And that will give us our answer. And if they hit enter and they don't cancel the script, then we will drop the database, wedding registration, which is the database we are going to be working with. And then we will create that database again, wedding registration. That's a tough little tongue twister. Then we will connect to wedding registration, and then we will execute the wedding registration schema.sql script. Again, a few things going on here. The first is that we're letting the user know we're about to drop the wedding registration database, and all data is going to be lost permanently. Basically, we're telling them right there, just letting you know, if you drop this, if it exists already, it's going to be gone. And then we prompt the user, and if the prompt is accepted, the script then uses the drop database and create database commands to create the wedding registration DB and connect to that database. Note that we don't include drop database if exists here, so we will see an error output the first time we create the database. Something nice to have that explicitly spells that out for us, so we're leaving it, but if you see that error, don't be alarmed, it's to be expected. It won't affect the outcome of the script either way. And then we're just using this /i command to execute pSQL from this file, and it'll run all of the SQL right here, which should create our table and with the proper schema. So to actually run this file, let's go ahead and exit pSQL here, and we will run another pSQL command to instruct pSQL to execute the file we just defined, which is pSQL-f for file, wedding-registration.sql. So if we run this, hit enter, it'll ask us delete and recreate wedding registration DB, return for yes, control C to cancel. I'm going to say yes. Great. We have an issue here. Did I do something wrong? Oh, I did. Let's check that out again. Yeah, okay, I see what I did wrong here. This extra parentheses. And it is nice. It says, hey, by the way, it gives you note that there's an syntax error at or near this position. That's not always the most helpful thing, but it then does give you a little bit more information here. So SQL can be tough at times to debug, but it is good to at least brush over it again, see what you missed, make sure things work. Let's try that one more time. Yes. Okay, cool. Drop database, create database. Looks like things worked, and we should be good to go. Now, notice, by the way, I did get this error. Database wedding registration does not exist the first time because that database did not exist, and we tried to drop it. So that was the error I was referring to, but again, it didn't matter. The actual error I got here is just because I had a typo in my script, and that's totally fine. So we should be good to go now. That's everything we need, at least to see that everything worked like we wanted to. Let's go ahead and re-enter pSQL, and let's go ahead and connect to our database. We'll say C, wedding registration. Cool, looks like it worked, right? And then let's go ahead and let's run /d plus. Ooh, very cool. So we see that we have a users table and a users ID sequence table. Now, we didn't create this. It was created for us, but again, don't worry too much about that. Let's go ahead and select everything from the users table. Cool. We see that all of the columns were created like we expect them to be. It would be nice to know if the data types that we defined are what they are, and there's actually a good way to do that. You can say /d plus and then the name of the table, which is users, and it gives us this nice little section. Let me just run that again. There we go. This nice little table that gives us a bunch of information about the users table that we just created. Now, the C command that we use to connect is just shorthand for connect, which we saw in the script, and the D plus command is actually a pSQL wrapper around some slightly more complex SQL that either provides information about all the tables in the database when supplied with no argument, or provides some information about the table specified if given one, like that we can see here. Now, there's so much going on here, it's probably not worth delving too much to the moment, but if you want to see the actual commands that the shorthand syntax is an abstraction for, or like wraps, you can enter P-SQL like this. You can say P-SQL and then use the -e flag and then execute the same commands. And then we'll see all of the internal Postgres stuff happening behind the scenes that provides us with these nice informative tables. So if we then go ahead and do the same thing, connect to wedding registration like this, and we run that same thing /d+, we will see that it actually executes all of the SQL right here, which is a lot, right? And if we do the same thing, d+ users, we'll see that here it's even crazier. There's a number of different queries that are executed to make all this come together. And so there's a lot of things happening behind the scenes. If you don't care about it, it's not super important. But it is good to know if you at least want to see that it's not magic, it is just regular SQL that's happening with a bunch of Postgres internal Postgres tables. So just some cool stuff to know, but we can quit this and let's go ahead and do our get dance. Get status. We have created 2 SQL files here that we've used to create our database and create our tables. Let's go ahead and add them both. Wedding registration.sql and wedding registration schema.sql. And then let's commit them. Added database creation scripts. And we should be good to go. So in the next video, we'll start handling environment variables so that we can actually connect to our newly minted database from our API.